Two additional characteristics of single-mode fiber that are important are cutoff wavelength and mode field diameter. Cutoff wavelength is the wavelength above which a fiber will support only a single mode. Wavelengths below the cutoff support two or more modes. The cutoff wavelength is determined by the fiber's refractive index profile, the length and bend of the fiber, as well as the cabling process and deployment conditions encountered during use. In a single-mode fiber, some of the optical power is actually guided outside the core. In fact, as much as 30% of the light propagates in the cladding layer of some fibers. The mode field diameter defines the size of the optical power distribution in the fiber. Multi-mode fiber has two important characteristics: numerical aperture and core size. Numerical aperture is the measure of the angular range of acceptance of light into a fiber. The angle over which a fiber accepts light depends on the refractive indices of the core and cladding glass. Core diameter is a fundamental design parameter of multimode optical fiber. The larger the core, the more modes of light can propagate through the fiber.
The actual conductor is a silica glass or plastic core. This core is surrounded by a refractive coating called cladding, which provides a reflective surface and causes the light to travel along the entire length of the core. The third layer is a buffer coating to protect against moisture and other damage. It also prevents light from escaping the strand and may have a color coating for identification purposes. Fiber optic strands are typically bundled into a cable. These strands can be grouped as either tight or loose buffered cables. Both types of cables contain some type of strengthening member, such as aramid yarn, stainless steel wire strands, or gel-filled sleeves. They are, however, designed for different environments. A tight buffered cable consists of one or more bundled fiber strands covered by an outer jacket. Often the outer jacket contains multiple layers to add structure to the cable and provide water resistance. In loose buffer cables, the fiber strands are contained within buffer tubes, allowing the strands to move freely while also providing additional protection for the strands. The addition of buffer tubes and other protective layers causes the cable diameter to fiber cable that is used outdoors is normally filled with a waterproof gel. The buffer tubes may also contain this gel, as well as a water-blocking coating between the inner and outer jackets. Both inner and outer jackets are made of materials designed to resist corrosion and add greater protection to the cable. Some cables also have a metallic armored coating for strength and to protect against rodents. Fiber specifications list the core and cladding diameters as a ratio. Multi-mode fiber is usually either 62.5 by 125 microns or 50 by 125 microns. Single-mode fiber is commonly 9 by 125 microns. Fiber optic cables have many advantages over copper cable, including immunity to electromagnetic interference and radio wave interference. They are smaller and lighter than copper. They are capable of greater transmission distance and higher bandwidth, and have less signal degradation. The greatest advantage is their ability to carry digital information over long distances at significantly higher rates than copper. For example, fiber optic cable may reliably transmit data up to 10,000 meters compared to a few hundred meters for copper. This means that fewer cables are needed, fewer signal repeaters are required, less power is used, and there is less maintenance. Collecting on a server, a technician miles away from the site can determine the status of an individual turbine or the entire farm. Fiber optic lines are thin, flexible, transparent strands of optically pure silica glass or plastic used to transport digital data via a light source. These strands are typically smaller in diameter than a human hair. A fiber optic strand consists of multiple layers. The actual conductor is a silica glass or plastic core. This core is surrounded by a refractive coating called cladding, which provides a reflective surface and causes the light to travel along the entire length of the core. The third layer is a buffer coating to protect against moisture and other damage. It also prevents light from escaping the strand and may have a color coating for identification purposes. Fiber strands covered by an outer jacket. Often the outer jacket contains multiple layers to add structure to the cable and provide water resistance.
Work a different way. They send and receive information using invisible radio waves, a technology called wireless because it uses no cables. Fiber optics works a third way. It sends information coded in a beam of light down a glass or plastic pipe. It was originally developed for endoscopes in the 1950s to help doctors see inside the human body without having to cut it open first. In the 1960s, engineers found a way of using the same technology to transmit telephone calls at the speed of light. Normally that's 186,000 miles or 300,000 kilometers per second in a vacuum, but slows to about two-thirds this.
Communication to occur between injects of a transmitter to produce optical fibers and an optical to decode the light pulses in digital form, either digital or analog. Also require use of a convert them to digital form. The transmitter is composed of an drive circuit and the interface circuit processor, making it compatible. In turn, varies the current to modulate. Finally, the optical energy into light. Light are sent through the transparent The receiver consists of an amplifier and the photodetector transmits electrical signals and must be capable of detecting. The signals received from the photodetector is the primary source of electric, and the sensitivity on minimizing this noise. The signal restorer can signal into a form circuitry, and receivers work together gradation across the network. Distance applications also either repeaters or optical light signal back into an electric generates a new optical signal. Repeater cannot distinguish different wavelengths. Multimode fibers. Repeater uses a laser to These are able to boost wavelengths of light, single mode or multimode. Another device that is an optical coupler, or this is used when necessary at multiple locations. Numbers that represent the percent. For example, 20. The cable communication system strands depending on fiber strands differed core in relationship to depending on the type of the light waves propagating a variety of paths. The path of a light wave as the mode or path of the light wave entering the refractive index of the class of the entering light wave will not propagate through. There are single and multi-modes. Both single modes are typically 100 outside diameter, smaller in a single mode. Single mode fibers are a micron.